Have you ever chatted with an AI like ChatGPT and just had that moment of, wait, how does it get it? How does it actually understand what you're saying? It can feel a lot like magic. Well, today we're going to pull back the curtain on that trick.
Okay, so first things first, let's get our terms straight. You've definitely heard of large language models, or LLMs. Yeah, we're talking about models like GPT or Llama. They're the ones making all the headlines right now. But they're actually just one piece of a much bigger, older field called natural language processing, or NLP, which has been trying to get computers to speak our language for decades.
And what's wild is that the secret to today's incredible AI, well, it was really unlocked by a question someone asked way back in 2014 about models that were way, way simpler. The question was simple, as you can see. Why do they work so well? That question, right there, is the mystery we're going to solve today.
To find that answer, we've got to start with a really fundamental puzzle. How in the world do you take something as fluffy and abstract as a word and turn it into something a computer can actually work with? The solution is a foundational concept called a word embedding. A word embedding is, think of it like a universal translator. It takes a word, say cat, from our human world of meaning, and it translates it into the world of math by turning it into a long, long list of numbers. And that list of numbers is called a vector. So, instead of seeing the letters CAT, the computer sees this unique numerical address. It's like a coordinate, a specific point on a massive, invisible map. This is the spot where the concept of cat lives.
Now here's the really cool part. How do these numbers get decided? Well, it's not some genius programmer figuring them out one by one. It's actually a side effect of something else. As the slide shows, you start by giving every single word a totally random list of numbers. Then, you give a simple AI a really simple job, like telling you if a sentence makes sense or not. As the model practices, it tweaks those random numbers to get better at its job. And in the process, something amazing happens. Those random numbers start to capture the actual real-world meaning of the words.
Okay, so the AI now has coordinates for every word. But so what? Why is that such a big deal? Because what comes out of this process isn't just a tidy list for a computer. It's something way more profound. The computer, just by trying to solve that simple little puzzle, accidentally created a map of our language. A whole conceptual universe where every word has its place. And the layout of that map, well, it reveals the hidden structure of meaning itself. Just take a look at this. If you go to the coordinate for the word France on this map, and you ask the computer, hey, what's nearby? You don't get random words. You get Austria, Belgium, Germany, Italy. The model, just by reading text, figured out that these things we call countries all belong together. And this is its superpower. This is what lets the AI generalize. It doesn't have to read every single sentence ever written. Because it knows that wall is conceptually close to ceiling and blue is close to red, it can make a really good guess about a sentence it's never seen before. That's a massive leap in learning. But the real honest-to-goodness aha moment, that comes when you look not just at the points on the map, but at the distances and the directions between them. This is where the geometry of it all just snaps into focus. It turns out that the relationships we have in our language, things like opposites, or verb tenses, or a country and its capital, they become consistent mathematical formulas. Abstract ideas become simple arithmetic. Think about this with me for a second. Let's do a little vector arithmetic. We take the coordinate for king, then we subtract the idea of man, and then we add the idea of woman. Where on this map of meaning do you think we're going to land? You land right next to the vector for queen. I mean, how amazing is that? The model didn't just learn words, it learned the abstract concept of royalty and its relationship with gender, purely through math. It's absolutely stunning.
And this isn't just some one-off party trick. This geometric structure holds up for all sorts of concepts. The journey from France to Paris is the same direction and distance as the journey from Germany to Berlin. The path from walking to walked is the same as from swimming to swam. The AI has learned the rules of our world as directions on a map.
So this powerful idea of learning a map of meaning, or a representation, it's not just locked into English. No, this principle is universal. You can use it to map pretty much anything. You can create one single shared map for two different languages, or you can get even crazier and map completely different kinds of information, like pictures and words, into the very same conceptual space. For example, some researchers did this with English and Mandarin. They basically told the model to build one map for both. And sure enough, it figured it out. It placed the English word dog right next to the Mandarin word for dog, go.
And here's where it gets really wild. Other models have learned to map images and text into one space, so an image of a cat gets plotted to a coordinate that's right next door to the coordinate for the word cat. The AI is learning the idea of a cat, whether it's seeing it as a picture or as a word.
So, how does this all circle back to the incredibly powerful AI we use every day? Well, everything we've just walked through, that is the fundamental building block for the whole thing.
Which brings us right back to our original question. What's the secret sauce? What makes modern LLMs so incredibly good at what they do? And the answer is, there is no new magic. The secret sauce is the exact same principle we've been exploring this whole time, letting a model learn a geometric map of meaning. The only thing that's really changed is the scale. Today's large language models are built on this very same idea, but they are just unimaginably bigger. Their maps weren't built from a few million sentences. They were built using a huge chunk of the entire internet, creating a map of meaning so detailed, so complex, that it lets them perform this massive range of tasks we see today.
So when you boil it all down, it's about building these incredible maps. We've seen that AI can chart the geometry of language, of abstract ideas, and even of the visual world. It proves that the relationships that govern our reality can be represented geometrically. And that leaves us with a pretty profound final question. What other parts of our universe are just waiting to be mapped?